Imagine this, a helicopter, packed with tourists, flying over one of the most famous skylines in the world. And then, suddenly, it just fails, disintegrates right there in midair. No warning, no mayday call, just a perfect day that in a flash turns into an absolute catastrophe. So how on earth does something like that happen? Well, in this explainer, we're going to peel back the layers on the hidden flaw that made it all possible. So let's set the scene. It's New York City, April 10th, 2025. We've got a Bell 206 L4 helicopter on a totally routine air tour. You know the kind. It takes off from Manhattan, zips past the Statue of Liberty, heads up the Hudson for those amazing views, and then turns back. For the pilot and the 5 people on board, it was just a standard, beautiful day for a flight. And then everything went horribly wrong. This timeline, pulled from flight data, shows the helicopter's last few seconds. And I want you to look at just how fast this all happened. At 15:14 and 47 seconds, it's flying normally at 675 feet. Just 4 seconds later, it's lost nearly 200 feet. 2 seconds after that, it's down to 250. And less than a second later, the last signal comes in at 125 feet. The entire disaster unfolded in just 7 seconds. Surveillance cameras actually caught the moment. Witnesses on the ground said they heard these loud bangs, and the helicopter didn't just fall out of the sky, it was torn apart. The entire main rotor system just ripped away from the fuselage, and the tail boom completely separated. The aircraft literally broke into 3 pieces before it even hit the water. So that brings us to the one huge question for investigators. An in-flight breakup like this, it's incredibly rare. It points to a massive, catastrophic structural failure. What kind of force, what kind of flaw could possibly cause a helicopter to just come apart like that? Well, the answer, it turns out, was hiding in a crash that happened more than a decade earlier, and what they found would change aviation safety forever. To figure out what happened over New York, we actually have to go back in time to 2011, to a remote forest up near Kapuskasing, Canada. Because there, another Bell 206L had an eerily similar accident. A main rotor blade separated in mid-flight. And it was inside the wreckage of that helicopter that investigators found the hidden killer. And here it is. This is a slice of the failed rotor blade from that crash in Canada. The fatal problem wasn't something you could ever see from the outside. No, it was buried deep inside the blade's main structural part, something called the spar. Just think of the spar as the blade's backbone. It's the piece that carries all the stress of flight. And it was inside this critical part that the failure began. The culprit has a name, metal fatigue. And you've probably seen it in action yourself. Think about bending a paperclip back and forth. At first, it's fine. But every single time you bend it, tiny invisible cracks are forming and getting bigger. And then all of a sudden, snap, it breaks. Well, the same thing can happen to aircraft parts that are under constant stress, flight after flight. And these images show that process perfectly. Okay, on the left, we're looking at the inside surface of that aluminum spar. See that dark, ugly patch? That's where corrosion started. It created the perfect little weak spot for a fatigue crack to form. And then on the right, you can see the proof. Each one of those curved lines, they're like tree rings, showing how the crack grew, bit by bit, flight after flight, completely hidden from sight until it was just too late. So this was the deadly chain of events. It all kicked off with a tiny manufacturing defect, a little gap or a void in the glue that was holding a weight inside the blade. Somehow, moisture got into that gap and started causing corrosion. That corrosion then started a fatigue crack, and that crack just grew silently, getting bigger with every flight until the blade just couldn't take the stress anymore, and it completely failed. But here's where the story gets even more disturbing. That 2011 crash in Canada, it wasn't the first warning. When investigators started digging, they realized this exact same hidden flaw had caused another fatal crash years before, revealing a deeply troubling and deadly pattern. Check out this timeline. We go back to August 2008. A Bell 206L1 medevac helicopter crashes in Indiana, killing all 3 people on board. The cause? A main rotor blade separated in flight. Then, 3 years later, you have the crash in Ontario. Same type of helicopter, same exact cause of failure. I mean, when you put the findings from these 2 crashes side by side, it is just uncanny. It's the same blade part number, the same failure cause, a fatigue crack, and the same origin point, a void in the adhesive inside the spar. It was the exact same hidden flaw causing the exact same catastrophic failure. So, after that first crash back in '08, the manufacturer, Bell Helicopter, issued what's called an Alert Service Bulletin. They came up with a new inspection procedure that was supposed to find these cracks before they could cause another disaster. The big question was, would it actually work? Or was this response just too little, too late? The bulletin basically zeroed in on this one specific section of the blade, telling everyone this was the high-risk area. The whole idea was to have mechanics visually inspect the surface of the blade in this zone, hoping they could catch the fatigue crack, if and when it finally broke through from the inside.
And the procedure they came up with? Well, it was surprisingly low-tech. They called it the wipe check. Mechanics were told to literally apply a solution with blue food coloring to the blade. They'd wait a few seconds, let the dye seep into any cracks, and then wipe it clean. If a crack had made it to the surface, some of that blue dye would stay behind, and you could see it. That was the theory anyway. So, the million-dollar question, did it work? The investigation into the 2011 Canada crash gave a definitive answer: nope, not at all. Get this, the blades on that helicopter had gone through 16 of these wipe checks. The very last one was done just 41 flights before the crash. But the analysis showed that at the time of that final check, the crack was either still totally inside the blade or at most 10 millimeters long on the surface, way too small to be seen reliably. The test had failed, and the consequences were fatal.
The fact that the wipe check was useless presented regulators with an absolute nightmare. They had a fleet of over 2,500 of these blades out there flying with a potentially deadly defect and no reliable way to find it. They had to do something, and it had to be drastic. So, on February 1st, 2012, Transport Canada dropped the hammer. This document you're looking at is an airworthiness directive. Now, an AD isn't a friendly suggestion, it's a legally binding order, and this one was about to have a huge impact on helicopter operators all over the world. The new rule was this: a mandatory retirement time for all of these blades at 1,400 hours. And that was a massive cut. These blades were originally supposed to last for 3,600 hours. This order basically threw away more than 60% of their lifespan. It cost the industry millions, but it was done to save lives. Any blade with 1,400 hours or more on it had to be scrapped before its very next flight. And this quote, right from the directive itself, is the final piece of our puzzle. It is a stunning admission. The regulators are basically saying, we can't find the crack, so the only way to be safe is to get rid of the blade long before the crack has time to grow. They couldn't fix the problem, so they had to remove the risk entirely. A hugely expensive decision, but it shows you the challenge of dealing with these invisible, hidden defects. So the story of these Bell 206 rotor blades is this incredible lesson in engineering forensics and how safety regulations evolve. But a more recent crash is a really stark reminder of what happens when investigators don't have the clues they need, and how a simple lack of data can leave everyone in the dark. Let's jump to August 2020. Another Bell 206 helicopter goes down, this time in Texas. The pilot actually survived and said he felt a sudden, violent vibration that made the helicopter totally uncontrollable. But the wreckage was just ravaged by fire, destroying all the critical evidence. So why couldn't they solve this one? The answer is painfully simple. There was no black box. The helicopter didn't have a flight data recorder or a cockpit voice recorder, and legally it didn't have to. All that crucial data that could have explained what happened in those final moments was just lost forever. The NTSB's final report just lays it out there. Without recorder data, a full investigation was impossible. And it leaves us with a really sobering thought, right? How many other accidents are still mysteries, and how many other hidden flaws might still be out there, undiscovered, simply because the data that could save lives was never recorded in the first place?